Here we are at Federation Square, an icon of the City of Melbourne, Australia. We're here to look at some interesting geometry in this particular piece of architecture behind me. What at first glance might look like a bizarre and random pattern turns out to be made up entirely of one shape pieced together into many different ways. This single right-angled triangle is used again and again to build up different shapes and eventually the whole structure. So what can we find out about this triangle? If we call this shortest length 1, then we can see that the longer length is made up of 2 of the shorter lengths. So we could call this longer length 2. This angle here is a right angle, so we can use Pythagoras' theorem. A squared plus b squared equals c squared. That helps us find the length of the longest side. 1 squared plus 2 squared is 5, so the hypotenuse would be the square root of 5. Interestingly, putting together 4 of these triangles makes another bigger triangle. If we look at the angles, we can see that these 2 angles are the same size and both triangles have this angle in common. The third angle for each triangle is a right angle, so both triangles have the same 3 angles, which means that they must be similar triangles. So if we add a 5th piece to these 4 pieces, we actually make another slightly bigger triangle. Now the 3 angles in a triangle always add up to 180 degrees. This angle here is a right angle, which is 90 degrees. So that means that the other 2 angles must add up to 90 degrees. Remember, this is the same triangle. It's just been flipped and rotated around. So this angle here is made up of those same 2 angles that add up to 90 degrees. So both the 4-piece and 5-piece triangles have a right angle. And we can also see that these 2 angles are the same and both triangles have this angle in common. So the same 3 angles are in both triangles. This means that the 4-piece triangle and the 5-piece triangle are both similar to each other and similar to this one small triangle. Now on this wall, the 5-piece triangular panel is actually put together with 5 other panels to build an even bigger similar triangle. This same process is repeated again, making a giant triangular fractal. When we use a simple process over and over to build a never-ending pattern like this, we call the pattern a fractal. Fractals can be seen in nature, in snowflakes and plants and mountain ranges, and they are now being used in engineering and computer science for things like shrinking and enlarging digital images and creating compact hardware. Once you start looking for it, you'll find even more geometry hidden in Federation Square and in all sorts of other works of architecture, engineering, and design.